Guys, hope you're all doing well. It's like day 10 of isolation and no one's caught the virus here yet that we know of, and we're all feeling good, just going a little stir crazy being in the house. So we're going to do a little bit more of the science stuff moving forward. So today we're looking at pushes and pulls C. It's on page 3 of the Lab Binder series. And you can just follow along, and if you want to fill out the pushes and pulls C, we're just going to be discussing the answer instead of writing stuff down. And then there's some reading online that I'm going to direct you to, and I'll have that in the Google Classroom. So what we need is 2 spring scales and 1 car. So we've got the car, and it's pretty sweet because it's like
fancy schmancy.
Yeah, no resistance and stuff. And I've kind of attached hooks here so we can push and pull it if we need to. And then we have our 2 spring scales, right?
Yes.
All right. And we're going to just go through them. So it says number 6, what happens when spring scale A pushes with a 2 Newton force on one side of the car, and spring scale B pushes with a 3 Newton force on the other side of the car? So do you want A or B?
B.
Okay, so I will push with 2 Newtons. Yeah, and you will push with 3.
Mm-hmm.
All right, so here we go. Okay, I'm at 2.
I'm at 2 too, but I can't get to 3.
Okay. So what happened?
It's really hard.
It's really hard. And so in order for you to get to 3, did you see what I was doing?
Yeah, you were letting go a little bit.
You're letting go a little bit. Let's try it again.
Okay, hold on, let me hold this better.
Yeah. Okay.
Okay.
So I'm at 2.
Yeah, I can't, at most I can get it to 2.5.
Okay, so only getting to 2.5, and like mine like keeps bouncing. So what do you think is going on?
I think because it has lesser force, you can push the lesser force with the bigger force, but in doing so, you're lessening this force. And yeah, I don't know how to explain it.
Yeah, so kind of going back to that Newton's third law.
Yeah.
Right? Equal and opposite. So we're pushing in opposite directions, and it has to be equal.
Yeah.
So when she gets to 3, so do I. You know, like it goes to 3. Unless I try and back it up and we try and balance it. And that's moving the car forward. So that kind of goes with our,
Oh, that's like friction.
Almost.
No, because like friction is the opposite force and it's pushing this way. But then like you have like a car. And the car is using something faster to push against it. And then you move.
Okay. Yeah, we're going to get there.
Science and stuff.
All right. So number 7 says, what happens when A pulls with a 5 Newton force on one side of the car and B pulls with a 5 Newton force on the opposite side of the car? So we need to do some finagling. Go ahead and try and hook your...
Rory successfully hooked it before.
Okay.
I'm a veteran.
I'm having trouble. All right. Okay. And so watch for 5 Newtons. I'm at 5. Okay, so what's happening to the car?
It's kind of floating.
Is it moving one way or another?
No.
Only when we adjust, right? Okay, but if we try and stay at 5, the car doesn't move. Okay. Any ideas as to why?
Because equal force and stuff. Because it would be the same for pulling if it was for pushing.
Right, so equal forces, right, in opposite directions. All right, and so now it says apply a 2 Newton pull with A and a 2 Newton push with B on the car. All right.
That's gonna make it go forward.
That's going to make it go. Good prediction. All right. So am I pulling and you're pushing, or how are we going to, am I pushing?
Pull. Yeah.
You want to pull? Okay.
I'm better at pulling.
All right. So let's start over here since we're going to go in this direction.
I don't know how we're going to get it to that.
Mm-hmm.
Sorry. It's a floppy hook.
Okay. So.
See, because like if I start pulling.
Yeah,
it's not going to work.
All right, so if we try and do that, you know, like it doesn't work.
Does not compute. Error.
All right, it doesn't compute, right? Okay, so for A, actually, wait, I got my load here, my black load from before. Oh, sorry. Let's try it with that. You pull, and I'll push.
Okay.
Okay.
I feel like it's going to be the same.
All right. So can you get it to 2 by pulling?
No.
No, can't even. You can get it to 1. All right. Do you think if we did these?
Maybe.
Okay, let me try and push it and see if I can get it to 2. No, even pushing it, I can't get it to 2. All right. More on that later, right?
If I do it this way though, I can.
You're at 2. Do you think I should? So you're at 3 this way.
Yeah.
All right, here, lift it up.
If we do it reverse.
Lift it up, and then I'm gonna try and push it at 2. Okay, I'm pushing it at 2.
No, it only got to 1.
Okay. So when I add a force from the bottom, and you're having a force that's pulling down,
Top.
and we,
Up.
yeah. Okay, so this is pulling down, and you're pulling up. They equalize.
Yeah.
Okay. All right. Cool. So 8A says for the pull and the push on the car, explain what happens to the car when forces are applied.
It doesn't move.
But for this one, sorry, for 8, when we had the pull of 2 newtons,
it definitely moves.
It definitely moves. And if we could make it move fast, if we had a longer table, maybe the floor, could we get it to 2 newtons, you think?
No.
It moves too smooth, right?
Yeah.
Because this
there's no friction. Well, there's probably friction, but there's not a lot of friction.
Not a lot of friction. Not like these.
Yeah, these things they slide. They slide and they get halted by stuff on the table. That's what friction. Meanwhile, Mr. Zoomy car over here is like, whee!
No friction, right? The wheels are really smooth. Like,
yeah.
If you
and they all move individually, which can help with friction. I lied. They don't move individually.
Yeah, they're on the same axle, but they're really well greased. And for you, people who do you scouts who do the
I watched a video on
races.
That. I watched a video on that with Daddy, and he said that you were supposed to have thin wheels like that.
Thin wheels, yeah. So there's less friction.
The friction, yeah.
Right, and then you can put graphite on the axles to make it run smooth too. Yeah, because there's less stuff touching it. All right, so going back to B, right? So 8 says 2 newtons pull and 2 newtons push.
Hey.
Are you listening?
Yes.
Okay, so 2 newtons pull and 2 newtons push. How could you use one pusher to achieve this same result? So if I've got 2 newtons going this way and 2 newtons going this way, how could I push? What would I have to do with just one push? What force would I have to get it to?
2. Okay, repeat one more time.
Okay, so if we've got 2 newtons pulling, right? 2 newtons pulling and 2 newtons pushing, how could we achieve that same result with just the pusher? See, and this demonstration didn't work real great because we couldn't get it to 2 newtons. But let's say we could. Let's say there was more force applied on this. There was more friction, or there was more standing in the way. how would we do it with just a push, right?
Just pushing.
Just pushing. What would we have to get this to for just pushing?
4.
You're right. So how did you come up with that?
Well, because you used 2 newtons before, and it didn't even get to 2 newtons. But if you had 2 of these and 2 of these, and they were both doing 2, then that equal 4, because math and stuff. And if you only had 1, then you'd have to do the math.
Sure.
Which would equal 4.
So we could change our numbers here.
Yeah.
Like
if you did 2, 3, then the force would be equal to.
So when I'm pulling this, it doesn't move into like 1.1.
Yeah.
But I could add this to it.
And make it easier.
Make it easier. So then we'd get both of them at half, maybe. Yeah. And then if I got rid of this, it would go...
Oh, that got to like,
1.1.
Yeah.
Again. All right, cool. All right. So number 9 is like the first question when we started this. What causes an object to start moving?
Force.
Perfect. A force. Okay. So
the force.
The force. Now, one thing we haven't addressed that we brought up is energy, right? So when you use force to move an object, you're transferring energy to the object. Right? So I'm providing a push, it's energy, and that causes it to move. And what is the energy of movement? What's that called? What sort of energy is movement?
Friction.
Do you guys know friction prevents movement?
Yeah.
So what is the energy? So list all the types of energy.
Electricity. Oh, kinetic energy.
Kinetic energy. There you go. All right. So you're transferring energy to the object. Kinetic energy is the energy of motion. All right. So that's what we're demonstrating here. And we're going to look for other examples of kinetic energy and movement. And then other forms of energy that don't show up as movement. So kinetic energy is easy to see. It's easy to demonstrate. But we'll also be looking for other stuff. Now, something else. So why didn't the loads move as easy as the car?
Friction.
Friction. All right. So that's another vocab word, right? So we got kinetic energy. We've got friction. We have force. So this friction, the loads didn't move until there was enough force from the spring scale to overcome the force of friction. So friction is an unseen force as well. Friction is the force between surfaces that resist motion. So when you apply kinetic energy and you do this, friction is what keeps your hands from moving even faster, right? And it generates what? Heat.
Kinetic energy.
Another type of energy. So it's an energy transfer from kinetic energy.
Yeah, friction also makes the zappies. The zappies, like if you go into carpet and you go with your feet on the carpet.
Oh, that's not friction though. That's something else.
I thought friction's part of it.
Yeah, it can add to it, right? So friction is a force between surfaces that resist motion. These have more friction on them from the table than our car does.
Ah!
Less friction.
Ah, it's attacking me.
Mm-hmm. Yeah, and so when you pushed or pulled lightly, you didn't use enough force to exceed the force of friction here. But when you push more, then you exceed the force of friction. Okay, and so that's the difference between an object moving and not moving, overcoming that friction. All right, and then what we're going to do is you'll go to the online textbook, and in our classroom, you're going to be reading the forces with you. And I think there's a couple think questions. If you could answer those think questions in the comments here in the Google Classroom.
But read it.
Oh yeah, don't just do the think questions. Read it. No notes necessary. Just read it. Answer the think questions in the comment section. Yeah, and so I'll list those pages in the Google Classroom.
I have to read more now?
Science. Hope you're all doing well. We'll talk to you later.